Alright everybody, welcome back to another video. In this lesson, we're going to be installing some of the required tools that we'll need to get started with this project. We're going to be installing Golang and Godot, as well as some of the tools we'll need to compile our packets using protocol buffers, both on the server side and on the client side. We'll also just be getting a feel for how these packets are both constructed and deconstructed, both on the server side and the client side. With that out of the way, let's dive right in. Firstly, we're going to of course need to install our game engine, which is going to be Godot 4. So if you just Google Godot and click on the first link. As of the time that I'm recording this, Godot 4.4 has not officially been released yet. So if you're watching this in the future, and it has been released by then by all means go ahead and download the stable release, which you can do with this button here. Otherwise, if you're watching this in the present and Godot 4.4 hasn't been released yet, you'll need to click on this little link that says experimental releases. The version that we're interested in is specifically 4.4 Dev 3, which is just the highest level of Godot 4.4 that gives us everything that we need, whilst also being stable and allowing us to do everything that we want to do. So I'm going to go ahead and download this 4.4 Dev 3 version of Godot game engine. And just for the platform that you are using, make sure you click the standard button, not the .NET. We want to use Godot script or GD script. So we're just going to go ahead and click the standard button right here. And once that's finished downloading, it'll just download a little zip folder. So we're just going to unzip that. And I'm just going to go ahead and put that just straight on my desktop. So now I've got my Godot game engine here on my desktop, and that's all that's required in terms of installing the game engine. So next up, we're going to actually need to install the Golang programming language to code our backend in. So let's go ahead and Google for Golang. And I'm just going to click on the first link here and click download. So it's going to go ahead and give me some instructions for my operating system, Microsoft Windows. But if you're using a different operating system, just go ahead and follow those instructions for your needs. But for Windows, it's just going to go ahead and give me a installer, which I can just fly through and click next and install. And once that's finished installing, we can verify the installation worked by just opening up a terminal and typing Go version. And if it installed correctly, you should see your architecture and the version of Go. I'm using 1.23.3 for reference, but as long as you're using anything, the latest release, there shouldn't be any issues. So as I hinted in the last video, we're going to be using protocol buffers to generate our packet definitions. And for that, we're going to need to install a compiler tool called protoc or protoc. And this is what we're going to use to take our packet definitions file and turn that into Go code and turn that into, well, there's a different tool that we'll use to turn that into GD script. For now, we're just going to install protoc. So we just Google it and click on the GitHub link. And we'll just come down here to the releases section. Make sure you click on the latest release. Scroll all the way down to the assets. And you should see your operating system here. So for me, I'm using Windows 64-bit, so I'm going to click the win64.zip. But if you're using OS X, you're most likely going to want to install this one. And for Linux users, you'll probably want to go and grab this one. Either way, these are just zip files with binary executables inside. So it's really nothing too fancy. We're just going to go ahead and unzip. And as you can see, there's just a bin folder with an executable inside. So I'm going to go ahead and take this protoc win64 folder, and I'm going to put it somewhere that I want to put on my path. So I'm actually going to go to my local app data directory. So I'm literally just typing %, local app data %, into my address bar of my file explorer. And I'm just going to paste that protoc folder right in there. Just make sure that it definitely has the bin subfolder inside. So now I'm going to open that bin folder and I'm going to copy this entire path. And I'm going to come into the start menu. I'm going to type path because I want to put the protoc executable somewhere on my system path so I can call it from anywhere. So we want to go edit the system environment variables, click on environment variables, of which path is 1. So under user variables, just double click on where it says path. I'm going to go ahead and click new, and then just go ahead and paste that bin directory right in there, and then click OK, OK, and OK. So now if you open up your terminal, a fresh terminal, you should be able to type protoc -- version, and it should tell you which version of the protobufs compiler you have installed now. So now you can call this from anywhere. So I'm going to go ahead and close my terminal. And if you're using Mac or Linux, you'll probably want to go ahead and put it inside this folder here, user local bin. And by it, I mean you want to put the binary executable from the zip that you downloaded on GitHub inside this folder here. And then you'll probably want to go ahead and change your path in your bashrc or zshrc file. So just tack this line on to the end of that file and you should be good to go. So we've installed our game engine, we've installed the programming language, and we've also installed the tool that we'll be using to convert our packet definitions into source code. Let's go ahead and install our text editor or our IDE. I'm just going to go ahead and install Visual Studio Code, which seems to be the most popular kind of software, and it has really good support for extensions. So we're going to be making good use of a few of these extensions. And I'll just run the installer real quick. And I'm just going to launch Visual Studio Code now. So the first thing is to create a new folder to open up. So I'm going to go ahead and create a new folder on my desktop. And I'm just going to call this Radius Rumble. But you can call this just the name of your project. So whatever you're going to be calling your project, give it a name and open it up in VS Code. Now inside of this project folder is going to be our server code as well as our client code and some code that's going to be shared between the two. So I'm going to go ahead and create a folder called server. And inside this server folder, I'm going to create another folder called CMD. And inside the CMD folder, I'm going to create a file called main.go. So this is going to be the main entry point for our server. To signify that it's a main entry point, we're going to give it a package called main. We're going to say that this lives on a package called main. Next thing, we're going to need to import something to print stuff to the screen. So I'm just going to import the format package. And then finally, our entry point function is just going to be called main, where we're going to print out hello world. So we can go ahead and save our main.go file. And if you open up the integrated terminal by coming up to the top, clicking terminal, new terminal, you can go ahead and run go run server/cmd/main.go, and we should see hello world is printed to the screen. So this demonstrates that we have the ability to run Go inside VS Code. But it's kind of annoying having to type go run server cmd main.go every single time we just want to run our server. So for that, we're going to install a couple of things. I'm going to go ahead and install an extension called Go for VS Code. So if you just search the extensions marketplace for Go, you should see this top one here with multiple millions of downloads. So that's usually a good sign. You can go ahead and click download and install on that extension. Next, we're going to go and create a debug launch profile. So if we come in here to the run in debug section, click on create a launch.json file, and we're going to click go and go launch package. We're just going to rename this profile to run server, just so it's a little bit more descriptive. That's going to be what appears up here. And instead of running the current open file, we're going to go ahead and go reference our workspace folder, which is just our project folder. So we're going to go to our server subfolder, cmd/main.go. So this is the file that we actually want to run. And that's what we typed in this command here. So we're going to go ahead and save that. And now if we press F5, it is going to go ahead and try to debug our program according to what we've put in our launch.json. But we get an error message down here, which conveniently tells us that we haven't actually installed the debugger. So let's go ahead and install that by just clicking this button down here. And we should see it says installing Delve, which is the Go debugger, succeeded. And it should say all tools successfully installed. You're ready to go. So let's go ahead and try that again. We're going to press F5 and it should open the debug console for us here and print hello world. Now, once we start getting into the networking side of things and opening up ports to run our server on, we're going to get a really annoying issue on Windows where it keeps asking you to add rules, exceptions to the firewall. And because the debug executable has a different name every time you press F5, it's just going to keep asking you every single time, do you want to add this? Do you want to allow this software to open up this port? So just to make it a lot easier for ourselves in the future while we're here on our launch.json file, we're just going to go ahead and declare the output path for our debug executable. And we're just going to put that in with the source code. And we're just going to call it debug.exe. We can go ahead and save that now. So the next time we run our software, press F5, the program that it creates is just going to be called the same thing every time. So it won't keep asking us. Great, so we've got that out of the way. Now we can actually go ahead and start defining our packets. So the heart of our project is going to be how we actually decide to communicate between the server and the client. Normally, if you've ever created like an API before, you would use JSON or maybe even XML as a way to send information across the wire. But we're not restricted by web standards with our game. We can kind of do whatever we want. And there are kind of better options out there if you aren't so concerned with human readability. Of course, we're still concerned with human readability to some extent, but we can actually use protobufs to sort of semi-encode our data in a binary format, which is going to be really convenient for when we want to send hundreds of packets every second. We can do that in a really fast and efficient and compact way with protocol buffers. So let's go ahead and define our protocol buffer packets. So as I mentioned before, these packet definitions are going to be shared between the server and the client, so they can both operate on some sort of shared communication grounds. If you want to change the packet structure, you only need to change the one place. So let's go ahead and sort of adjacent to our server directory, we're going to create a new folder called shared. And inside our shared folder, we're going to create a file called packets.proto. And this is going to be our protobuf packets definition file. So these files always start out by telling the protobuf what version we are using. So we're using proto 3. We're also going to give a package name. We're just going to simply call this packets. And we're also going to tell it where we want our output Go code to live. So which Go package do we want to output all of this source code to when we compile our packet definitions? So we're going to make a new option and we're going to call it, this is a special name called Go package. And we're going to say we're going to want to put it inside a folder called pkg, and we want it to live inside a folder called packets. And this is also going to be the name of our package, packets. So you'll probably notice there's no like syntax highlighting or anything here. So we can actually install another extension called VSCode Proto 3. So we're going to install this. And this is actually going to do a few things for us, but first and foremost, it's just going to give us some syntax highlighting and autocomplete features. And I'll get to what else this extension can offer us a little bit later, but I highly recommend this. It's not required, but it's highly recommended. So we can actually get straight into defining what a packet is to us. So we're going to go ahead and make a new message called packet. And for us, a packet is nothing more than a message along with a sender. So it kind of makes sense. someone has to have sent the message, and the message has to have some data. And we're going to bundle those two things together, and we're going to call that a packet. So the sender ID is going to be the first piece of information, and that's just going to be an unsigned 64-bit integer. We're going to be using integers for IDs in this course. And the second thing is one of some sort of message. And a message can be many things. We're actually going to define our own custom type for these messages. So let's make one called chat message. So we're just saying we're creating a custom kind of message, and it's going to include a piece of information. That piece of information is what the person wants to say. So if I'm sending a chat message from me to you and my message is hello, then this is going to have a value of hello, which is a string. And this is going to be the message that contains that string. And this is going to be a packet that comes from me and contains one of what? Well, it can contain a chat message. And we're just going to, if it does contain a chat message, we're just going to refer to it as chat. It could also contain something else, like maybe, for instance, if we have a kind of message that the server will send to the client when their ID has been assigned. So say you just join the game, the server needs to refer to you as something, so it assigns you a new identification, and you obviously need to know what your ID is. So the server is going to send that to you in a ID message. And because we're using unsigned 64-bit integers for IDs in this game, that's going to be the kind of payload that this message has. And, well, that could also be something that is bundled as part of a message in a packet. So you can sort of see how we are going to keep adding more and more messages here, and we're going to have to keep adding more and more messages here. So this is going to be one of these files that's going to be constant throughout the rest of our project, and we're going to keep adding more and more functionality to this file. So this is a very important file here, and this is a file that we can actually compile into source code. So that protoc software that we installed and put on our path earlier in the video, we're actually going to be able to use that now. Well, first we actually need to install something that's just going to allow us to create Go source code out of the protoc tool. So we're going to go ahead and run go install google.golang.org/protobuf cmd protoc gen go at latest. And by the way, these commands are all on the blog post, which I talked about in the previous video. So a link to this part 1 post will be in the description, and all of the commands will be available. You can just click this little copy button here, and you can paste it straight into your terminal. So if we run that, then we can go ahead and actually compile our packet definitions. So we're going to use protoc. We're going to give it an input of our shared folder. So that's just referring to this particular folder here. That's where our input packet definition is going to live. We're going to tell it the output directory is just going to be the server folder. And we're saying the thing that we want to compile is this file right here that we have open. So if we run that, it's just telling us that it doesn't recognize that we have protoc installed. It's a lie. What we need to do is actually just close VSCode and open it up again. And if we just press the up arrow on our keyboard to get that command again and run, we should get no error. Instead, what we'll get is a new folder inside our server directory called pkg. And inside that, we're going to have a folder called packets. And then inside that is going to be our source code that we've just compiled from our packets definition. So this is a file that you shouldn't edit. This is generated from protoc, but it includes everything that we need to be able to construct the packets that we want. And from these, we can use the protobuf package with Go to actually serialize and deserialize these messages. And this is what's going to allow us to seamlessly communicate with the client. Every time we want to add a new packet or change an existing packet, we're going to need to rerun this command. It's maybe not so convenient if you want to get your workflow going and you maybe don't want to have to keep finding this command and running it every time. That's where that extension that we installed, the VSCode Proto 3 extension, comes in handy. Not only does it give us syntax highlighting, but it actually allows us to automatically run this command every time we save this packets.proto file. In order for that to work, we need to create a settings.json file. So under .vscode, click new file and settings.json. And I'm simply just going to copy the code from my blog post here. I'm just going to paste it in. And I'm just going to say where my project folder actually lives. And we're just referencing the shared folder as well. What I found was that this needs to be an absolute path. You can't really just use a reference to the workspace directory like this. That won't work, unfortunately, for this particular setting. You need to use an absolute path. If you're on Windows, you need to escape your backslashes. And you also need to use a lowercase letter for your drive path. For some reason, like, so if you're using like C drive, you need to put a lowercase c for whatever reason, otherwise it won't work. But with that said, if you go ahead and save the settings.json file and come back to your packets.proto file, when you press Ctrl S, it should automatically run your protoc tool and recompile your source code. So for instance, to demonstrate, I can go ahead and delete this pkg folder. And now, theoretically, instead of running this command, if I just press Ctrl S in this file, it will actually go ahead and recreate that pkg folder that I just deleted. Or say, for instance, if I want to delete one of these messages, I can do so and save, and it will modify my packets.pb.go to get rid of all instances of our like ID message stuff. So if I do like a Control F for ID message, it doesn't pick anything up. Whereas if I go ahead and add those back in, press Control S, if I search for ID message, now I'm getting plenty of stuff. So this extension is automatically recompiling my source code every time I change this packets.proto file. So that's really good. Very, very useful. Not required, because at the end of the day, you can just run this command, but I can guarantee you will forget and it might cause you some headaches. I've been there, and I'm sure many of other people have been there as well. So with all that said, there's a couple of things that we still need to do. First of all, we still can't really use the packets from the source code that we've compiled, because we've got a couple errors here. It's just saying that we haven't installed these packets that it's trying to import. In order to do that, we're going to need to initialize our project. In your terminal, just make sure you're in the server directory, so you can type cd or change directory into server. And now that you're in the server directory, just run go mod init. And here you'll give a name for your project. So I'm just going to keep it simple and call my project server, and I'll press enter. So now we've actually created a project, and you should see this go.mod file here. What you can do now is you can type go mod tidy, and that's going to go ahead and install all of the dependencies that you're trying to import. So that should satisfy these two error messages here once it's finished downloading and installing those modules. So now you can see those red squiggly lines have gone away, and all is right with the world. What this also allows us to do is import our packets package. So in our main.go, instead of just only importing the format package, let's go ahead and import format, but also server, and this is the name of our project, /pkg/packets. And that's just importing this. And you can see that this generated file is a member of the packets package. So we are free to use anything that we see in this file as long as we've imported our packets properly as we have. So now instead of printing hello world, let's go ahead and create a packet. So I'm going to type packet equals reference to a packets.packet struct. I'm going to give it a sender ID, or if I'm not sure, I can actually press Control Space and it'll tell me the kinds of members that this struct expects. So I'll give it a sender ID, and I'm also going to give it a message. For the message, we're going to use one of those chat messages that we created. So packets.packet_chat. And it's expecting a chat message. So let's just go ahead and put that in. And this one is expecting a string called message. And if you think this looks a little bit complicated, it definitely is, and it can definitely be streamlined, which we'll do in a minute. But for now, it looks like we've just created our very first packet, and let's go ahead and print it out and see what we get. So I can press F5 after I save. So we see our sender ID, we see our message, and we see the payload for our message. So that looks pretty cool. Although it is kind of a lot. It's kind of a lot of code just to create one simple message. We can extract some of this functionality and make it a little bit easier on ourselves. And we're going to achieve that by putting a new file inside the packets folder. I'm going to make that called util.go. And util.go is going to be part of the packets package as well. We'll type packets. And the first thing that we're going to do is we're actually going to create an alias and expose a type that's internal to this generated code, namely the is packet message. So this is an interface type that, because it starts with a lowercase letter, we actually can't access it from outside this script. But because it is part of the packets package, and our util.go is also part of the packets package, we can just expose it ourselves here. And we're at the same time going to rename it. So we're going to call it simply message. I'm going to set that equal to this is packet message interface. And this is an interface that many functions in the packets package expect as arguments. So it's going to be worth our time to have this so that we can type things properly. On top of that, we said that we were going to try to streamline a few things. So let's go ahead and create a helper function to create a new chat message. And it's going to return this messaged interface that we've just redefined up here. And we're actually going to go ahead and return essentially this thing. Except we don't actually need to put packets dot because we're actually part of the packets package. And instead of hello world, we're going to return the given message string. So that's a good little helper function, and it means that we can simplify our main.go code to just packets.newChat. And we'll give it an argument of hello world. So as long as we go ahead and save that and press F5, we should get exactly the same thing as before, only now the code looks a lot neater. And this is going to become another common theme in this tutorial series. Every time we want to send a packet from the server to the client, we're probably going to go ahead and create a helper function in this file. In fact, while we're at it, we might as well create a new ID helper function to help us create ID packages. And it looks like Copilot already knows what we want to do there, so we can go ahead and save that. And let's test it out. Instead of creating a chat packet, let's just create an ID packet. And let's just say that the user's ID is going to be 420. We'll go ahead and save that, run it. It says here we're getting an ID of 420. Let's go back to our previous example. And let's see if we can turn this bad boy into a string of bytes that we could actually realistically send over the network. Well, for that, we're going to need to import the proto package from Google. So google.golang.org/proto-buff/proto. And this is going to unlock a series of functions that we can use, for example, the proto.marshal function. And we can see here that this returns the wire format encoding of a message. Essentially, if you give it a message, it'll give you back a slice of bytes and also maybe an error. So we need to capture both of those things. So let's call the slice of bytes data, and let's call the error error, and we'll assign that to proto.marshal, and we'll give it our packet. And we can just do a quick check to see if there was an error. I'll just panic on that error, which will stop our execution and print it out the error message. And now we can actually just go ahead and print our data. So this is our slice of bytes that we're going to print. We can see what actually gets marshaled. So it turns our packet, which looks originally like this, into a slice of bytes that looks like this. And we should expect to see remnants of the message inside here. So this would be the H. No, this would be the H. This is ELLO space WORLD. I think there's a comma in there, but yeah, you get the idea. And that kind of makes sense. We should expect to see, if we give it a string, we should expect to see an encoded string inside of these bytes. But this definitely looks like something we could send to a client, which is a great first step. Just in the spirit of exploration, let's pretend we received this string of bytes from the server, or maybe we received it from the client. So let's just get rid of all this, and we're kind of role playing now as someone who received these bytes. And let's say that we've captured these bytes into a variable called data. So what we can actually do to turn these bytes back into a packet and see what it actually is we first need to make an empty packet, just like that. And now we can pass that empty packet into the proto.unmarshal function. You can see this unmarshal function will pass the data and it'll place the result into the given message. And it might also return an error. So we need to try to look for an error as well. Proto.unmarshal data into packet. And sort of similarly to before, we're just going to panic if we see an error. Otherwise, we can actually print our packet. So notice I've not typed the word hello world anywhere in the source file, but if I press F5, we get an error. Oh wait, no, we don't get an error. We don't get an error. I just typed print. We need to do fmt.println. So I think the print function must just be printing the memory address of the packet. So if I actually print that properly and run it, we see the message hello world, and we also see our sender ID coming just from this slice of bytes. So this is showing us how we can deserialize bytes into protobuf packets on the server side. So yeah, it's pretty easy to serialize and deserialize packets on the server side. But how do we actually go about doing that on the client side? Well, let's go ahead and first create our Godot project. So we're going to come back to the desktop here and open up Godot. And we're going to go ahead and create a new project. And we're just going to call it client. And we're going to put that client folder inside of our project directory. Just in here. So sort of adjacent to our server and adjacent to our shared folders. So it should say project directory / client, and project name is just going to be client. And click, you'll probably want to select the compatibility renderer if you're going to be exporting for the web, but you can also change this later on. So just click create and edit. And now this is the Godot editor. we're going to need a way to compile the packet definitions proto file into Godot's scripting language called GD script. And in order to do that, there's a pretty neat little project called Godot buff. So if you come to, you can just Google Godot buff, come to the GitHub releases section, and just download this source code. And the link for this will also be in the description and in the blog posts. So the really cool thing about this is a Godot editor plugin. So it's very easy to install. All you need to do is extract it. It comes in a zip. And once it's extracted, we'll just open it up. And you should find an add-ons folder. Copy this add-ons folder and paste it into your client folder inside your project directory. So it should be amongst all of this Godot related stuff. Just paste that add-ons folder right in there. And now if we go back to the Godot editor, click project, project settings, plugins, and we should already see it here because we've placed it inside the special add-ons folder. So all you need to do is click the enabled checkbox right next to where it says Godot buff, and then click close. And what that does for us is it gives us a new tab here on the left-hand side, right next to the file system. You can click on this tab, and it's asking for an input protobuf file and an output GD script file. For the input protobuf file, we're going to go click the 3 dots here. We're going to go up a level. Then we're going to go to our shared folder and then double click on packets.proto. This is our packets definition file that we wrote earlier. And for some reason, it sort of asks us if we want to overwrite this folder. We're not overwriting this folder. We're just using this as our input. So it's all right to just click OK here. And now it's asking us for an output GD script file. So we're going to click the 3 dots again. And this time we're just going to call this packets.gd. So just type packets here, make sure GD script is selected here and click OK. So you should see for the input, it should say shared/packets.proto. And in the output, it should say client/packets.gd. And you can go ahead and click this compile button. And it should say compile success done. So what has that actually done? Well, if we click back to our file system tab, we should see a new script. And if you don't see a new script here, you can just go ahead and click project and then reload current project. And here we see our packets.gd script. And this is a generated source code from the Godot buff plugin. So this is a pretty big source code file, which just gives us this is pretty much like the Godot analog of this file here. So these are both generated source code files that come from our packets definition file. So this is how we can share the same packet definitions between the client and the server, and the respective tools, whether it be protoc or Godot buff, will take care of everything for us. The only annoying thing is every time you make a change to this packets.proto file, you're going to need to remember to come back up here, click the 3 dots, click up, shared, packets.proto, and then come here and then double click this packets.gd and click compile. You're going to need to remember to do that every time you make a change. So you might forget and it might cause you headaches. And sometimes you do it, but it doesn't really recognize that you've done it. So you need to come here, click project, and then reload current project. So that's sort of the only downside of this. But ideally, we're not going to be changing our packet structures that much once we get sort of off the ground. It might feel like a lot in the beginning though. Cool. So now we can actually sort of play around on the client side and start making some packets. So what we're going to do is we're going to make a new script. So you can right click this res folder here in the file system and click create new script. And we're going to call this one main.gd. Now double click main.gd and it should open it up in the script editor here. And we're going to go ahead and declare a constant And this is going to be our packets this is sort of going to be like our packets library. We're going to use this to access things inside this packets.gd file. So we're just going to give it the path to a preload packets.gd. And by just having this, it's enough to get some autocomplete on stuff that's inside this script. So if I actually go ahead and create a piece of code that's going to get run when this node becomes ready, I can actually go ahead and type bar packet equals, and then as soon as I type packets dot, it's automatically going to start suggesting things to me. So we want to create a new packet, and then we need to do dot new, since packet is a class. And let's go ahead and set the sender ID, sort of like we did back on the server side. So we got a method here called set sender ID. Let's go ahead and set that to 69. And let's sort of try to recreate the same chat message that we created on the server. So the way that you do it in Godot is slightly different. So you need to create a new variable just for the chat message. We set that to packet.newChat. And the chat message now has methods available to us, namely set MSG. And we're going to set that to hello world. So now, if we actually go ahead and print our packet, we should be able to run the game. So it's just saying no main scene has been defined. So let's just select the current scene. Or rather, we need to create a new scene. So let's actually just go ahead and create one now. So we'll go back up to this 2D tab. We'll create a new root node. Let's just make it a 2D scene. Why not? And we'll attach our main.gd script to this scene. So just click and drag the main.gd script onto this root node here. Save that as main.tscn. And we're just going to click run now. I'm going to select the current scene as our main scene. And now if we look down here in the output console, we see sender ID 69 and the chat message is hello world. So here we're able to construct packets on the client side as well. It's just done slightly differently. It's good to keep in mind. So let's see, what does this look like when we convert this into bytes? How are we going to send this to a server, for example? Well, again, the GD script API is slightly different. The way we do it here is we actually bar data equals packet.toBytes. Yeah, so if you're unsure about what this actually returns, you can hold Control and click on it. And it says here that it returns a packed byte array. So I was sort of wondering whether or not it returns an error code as well, but no, it's just a packed byte array. So that's the only thing we need to capture, and we're capturing that in our data variable. And now we can just go ahead and print the data, which we know is a packed byte array. And we should expect to see some pretty familiar looking numbers here. And here's our numbers again. There's a HELLO, and then this is a comma. This is a space. WORLD exclamation mark. So we've got our data, same as we had before. Let's go ahead and try what we did before as well. Let's create an array called data and pretend we know nothing about the message or the sender ID. We're just going to pretend like we received this over the wire somewhere. And let's go ahead and try to deserialize that into a protobuf packet. We're going to create an empty packet. Did I do that right? Yes. And now we're going to use the fromBytes method. So this is again slightly different from how we do it on the server, but we basically just do packet.fromBytes data. And then we can go ahead and print our packet. We should expect to see our message. And there we go. So again, seemingly like magic, knowing nothing about the message or the sender ID, just from these bytes alone, we're able to reconstruct the type of packet, the message, and the sender ID. Well, this is certainly a pretty interesting Hello World program. We can create packets in Go, we can create packets in Godot, and we can serialize and deserialize in both languages as well, all using the same packets.proto file. We've installed all of the tools that we're going to need in the future, and we've introduced a few of the main characters of the series, namely this file here and our util.go file as well. And we should be feeling pretty good about ourselves. We should be feeling confident that we can go ahead into the rest of this series and know that we're sending packets in one of the best ways that we can, one of the easiest ways as well. In the next part, we're going to be setting up a WebSocket server, and we're going to be establishing client connections from Godot. And we can actually send these packets that we've been working on building. We can send them in real time, deserialize them on the fly, and then serialize responses as well, and start talking between the server and the client. So that's going to be in the next part. But for now, thank you so much for watching, and I hope you have a nice day.